All right. Hello, everybody, and welcome to the stream. Hope everybody is doing well tonight. We are going to pick up where we left off on the last stream, and that is parsing our new scene file format. And then after we're done with that, which I'm suspecting we'll finish tonight, we'll move on to some more of the logic to instantiate some of these entities and get some of this stuff up and running so we can at least render the scene, and then hook that up to the renderer and go from there. But before we jump into that, though, I do want to just take a quick second and thank the supporters of the channel, starting with our elite partner, Javier Lazaron, followed by our partners, Graboli's Inc. and Matt Osgard. Those are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you guys very much for that support. It's greatly appreciated, and it helps me cover the cost of running this channel and project. It covers things like software licenses, hosting fees, eventually assets, things of that nature. So thank you all very much for that support. Again, it's greatly appreciated. Of course, I would be in error if I did not give a big thank you to all of you folks, the viewers, whether you're joining us here live on the Twitch side, or if you're joining us on the YouTube side live, or if you're just catching the VOD after the fact. Thank you guys so much for being here. Without you guys, none of this would exist. The channel, the project, none of it would exist or be here. So I appreciate each and every one of you, and thank you very much. Maget's up. How's it going? Good to see you. You are first, indeed, in chat tonight. Welcome. Okay. So in terms of, getting things done off camera, I didn't really get an opportunity to get much of anything done between last stream and this stream. Simply because I frankly didn't have time. So we're pretty much picking up almost exactly where we left off on the stream last night. The only thing I really got to write was this block of code here, which isn't much, but, it's something. So I started actually parsing the hit shape type of entity, and we have an example of that here over on the right side of the screen. And so the first thing I decided to tackle was the tags, right? So just to reiterate, tags are a comma separated list, right? So we can have some other thing or tag here, just like we do down here. And that's just all of the tags that I can have associated with it, right? I'm actually considering making tags. I'm actually considering hoisting that up a level. And having that be just sort of a generic entity property that any entity can have. And actually, I think I might actually do that now, because I've kind of been going back and forth on it, but I think it's probably going to be a pretty valuable thing to be able to tag stuff. So I guess let's go ahead and do that. I kind of wrote the tag parsing stuff within the hit shape entity configuration section, but I think we should go ahead and split that out to sort of the more generic level of things. So I guess what we'll do is we'll go ahead and we'll do base entity. Actually, I should probably look at hit shape entity, right? And I'm actually going to take tag count and tags out of here and go to the base entity, and I'm going to put it here, right? So base entity will have that, and that essentially means that that we can use those tags for more than just sort of evaluating collision shapes versus volumes, right? So that doesn't really change anything in terms of our, how our entities are configured within the level file. That is all pretty consistent with what we already had. So I think all we really need to do then at this point is to just hoist this up rather to the more generic level of things. So we can actually do all of that right here, right? Now that being said, all we essentially do is we get that value from the KSIN as a string, and then we perform a string split on that, splitting it by comma, and we do trim each entry and we do eliminate empty entries, right? Just to make sure that we don't have any extras there. And then if we actually have results coming back from that, then we go ahead and we set up an array and create k-string IDs for each one of those. And so just as a quick reminder, a k-string ID is very similar to how a k-name works, only a k-name is case insensitive versus a k-string ID is case sensitive. So it maintains the casing of the string, right? So that means that, if you've got one string, so that means if you've got one string that is, tags with a capital T, and you have another string that is tags with a lowercase t, these two will be separate k-strings. Versus if you're using k-names, they would wind up being the same. So just bear that in mind, because we're going to need, more than likely, we're going to need that sort of uniqueness in our tags. Spiro, you are indeed second. Welcome. How's it going, buddy? Let me give a quick shout out to Spiro, actually, for those of you who aren't following him. Spiro is always doing super interesting stuff on his stream. He goes over tech news every day, things about the tech industry in general. It's usually pretty entertaining to watch. Things about, stuff getting hacked, or I use the term hacked loosely. It's usually S3 buckets being unsecured, but he goes over stuff like that. But he's also building a game whose engine is built in C, and he's using the browser's DOM, or document object model, to act as his renderer. So it's super out of the box thinking. I like it a lot, and I highly recommend you guys go check him out if you haven't already. All right. So we have our tags. So that eliminates this. And then, so all we really need to parse out of this is the shape type and the radius, right? So radius is easy. We can go ahead and get that pretty quickly. So let's go ahead and do that one first. Right, so we'll go ahead and do, wrong button. All right, so for radius, we want to do an F32 radius. And we'll just default that to 0. LSR, good to see you. How have you been? Welcome. So I guess for the hit sphere, we'll say if we don't successfully parse it. So we'll say KSIN object property value get float. The object is just going to be the object that's passed in. The name of this is going to be radius. So that's the name of the property that we're retrieving. And then we're just going to write that out to the address of radius. If for some reason we don't have a provided radius, we're going to default to 1.0, right? And we're just going to set that up as a rule. And we'll say radius equals 1.0. Yes, I'm fully aware of, I could have just set it to 1.0 and then not have this if check. I figure this is a little bit more readable. Although, I guess, I don't know about that, actually. Actually, I feel like this is a little bit simpler. So let's actually just do, let's just do that. Right? So that's all there is to parsing radius. And then shape type is going to be a little bit different, right? So shape type is going to be, ultimately it's going to be sphere or rectangle, but we may add others down the road, right? So we're going to say Illumina shape type. And we're gonna do Illumina shape type. Should we even default this? I guess we could default it, right? We'll say, whoops. We'll default it to sphere, right? And then what we'll do is we'll go ahead and say if, actually, I guess we'll have to do an extraction of this first. So we'll do shape type string, right? And then we'll do if not. Actually, we don't even need to do this here either. We can actually just skip this. So I'm going to say KSON object property value get string. Right? We'll do obj. In this case, we want shape type. And we are going to output that to the address of shape type string, right? So we'll say if shape type string. Thank you for the follow. Appreciate that. Oh, you used NeoVim, that deserves a follow. Yeah, that's funny. I appreciate that though. Thank you very much for the follow and welcome. I also did get my my notifications showing. I just had it layered wrong in OBS apparently. So I know that was broken last stream, but it works now. Okay, so if we have shape type string, then I'll just go ahead and do if string equal I, so case insensitive, right? We're going to compare shape type string. And Mahmood, good to see you over there on the YouTube side. Welcome. How have you been? So we're going to compare this to sphere, right? So if we have sphere, then we'll just say simply that, right? And then actually, let's go here. And we'll do else if, right? And we'll compare this next to rectangle. And then we'll just change this to rectangle, right? Otherwise, we'll do a k error. Oops. Unrecognized or unknown shape type of, and we can spit out the string, was provided defaulting to sphere, right? And to this, we'll say we want the shape type string, okay? And then we're also going to do this down here. Now, technically speaking, this block and this block isn't needed because we default to it up here. But just to make things a little bit more explicit, right, we're going to go ahead and add that just in case for some reason this ever changes. So by the time we get down here, we should be able to know what shape type we're dealing with. So we'll say if, I guess we could do, probably just do I want to do a nested switch? Yeah, I guess we could do that. We'll switch on shape type. Populate that. And if we have a sphere, then we're going to go ahead and do this. Right, so we're only going to parse radius if we have if we have a sphere, right? Otherwise, we are going to go ahead and parse a rectangle. So a rectangle is actually going to be parsed as a vector 4. So we'll say r equals vec 3, 0, right? And then we'll do case and object property value get vec 4. So we want object. The name in this case is going to be, how did we say we were going to do that? Was that extents? Extents is technically 2 sets of... No, I think this should be fine. Extents. I think extents will be fine. And then we'll output this to the address of R, right? What is this complaining about? Oh, I did vec 3, 0. That should be vec 4, 0. Okay. All right. So at this point, we should either have a radius or extents based off of what type of shape we're dealing with. And at that point, we can go ahead and eventually, once we actually have the entity set up, we can actually write that data over and we're done. Let's see. I'm good. Thank you for asking. Which desktop environment are you using for blurring windows? So I'm actually on Wayland now, but KDE Wayland, I should say. However, the blurring effect of this is actually a little bit of a hack because there's an issue with WES-term on high DPI monitors running in Wayland mode. So I had to do a little bit of a workaround that's kind of janky, but it works. So yeah. Why did you make KSON instead of using JSON? So there's a couple reasons. The primary reason behind that is we really wanted to go through the exercise of sort of designing a storage format and writing the parser for that, and being able to use that for our serialization. We wanted to go through that exercise. Initially, this was only going to be used for scenes. But the more I thought about it, I'm like, this would be useful for a whole bunch of other things within the engine. So I standardized it and then, made the KSON sort of set of functions, if you will, to go ahead and work with KSON objects and arrays and all that stuff. And we wound up with this. This is also a simpler language than JSON. So there are aspects of it that we don't have to have. For example, we don't have to have like a wrapping object at the root level. We don't have to have like a open or close brackets or open or close braces at the top level. And then also we don't require any commas between members, whether they're named members or members of an array. We don't require that stuff. So we kind of wanted to make something from scratch and just kind of illustrate how you might do that. And then it's actually wound up being super useful since. And I don't have to rely on any sort of JSON parsing library to try and handle whatever slop people try to put in as JSON. Because you've got your standard JSON, you've got strict JSON, then you've got JSON 5. And I just didn't really want to get into all that. I didn't want an external dependency. So there's that. All right. First time chatter, Ali the Bug Bunny. Hello. Welcome. Let me see. Let me catch up on chat here. I actually need to scroll up a little bit further. Standards are high. Yes. This is going to sound special, but what C language are we writing in? I mean, just plain C. At the moment, I'm actually doing... Did I actually switch this to C99 or am I still on C17? I think I'm on C99, but I might have actually had to switch to C17 for something. I just can't remember what. What was that? Was it static asserts? No. Let me look at the build file. Yeah, we're on technically GNU 99, right? Because I am using a couple of GNU extensions. Or actually, I think I'm just using one GNU extension. So it's not quite C99, it's GNU 99. Let's see. So plain C without any additional symbols after, it's the OGC. Not quite the OG, but yeah. Is the engine ready to make a game for a jam at this point? I would say no. There's a few critical things that we're missing. We have a lot of the systems in place to technically make it. However, before I would actually recommend shipping a game on this, there's a few things that we need to run through. One of those things needs to be an optimization pass. Another needs to be, probably even before that, a stability pass, right? To catch all of the particular non-happy path types of problems we can run into. I know of a few off the top of my head. And then we also need a release packaging system to handle our assets in release mode, as well as probably some tweaks to the actual release build, as well as we need some sort of, in addition to packaging of assets, we need some sort of way to sort of make sure that everything is wrapped up in a deployable package somewhere, right? And so there's a few steps that we're going to have to do for that. So we're not too far off, but, those are some of the things that we would need to do. Right now, I'm kind of going for quality of life improvements at the moment. Let's see. Only familiar with newbie levels of CSS, HTML, and a year or so in C#. Nothing wrong with that. And Lua. Yeah, there's nothing wrong with that. You got to start somewhere, right? So that makes sense. What's the project? Sounds like an engine or something as a base. So there's technically two projects, right? There's the game engine that we've been building for the last 4 years. And I say 4 years, it's technically calendar years. Because I put less than full-time hours, or less than part-time hours rather, into this every week because I do work a full-time job. So, and also I've been, I made tutorials at the beginning. There was lots of video editing, lots of overhead and running the channel and stuff like that. So I say 4 years, but in terms of if I were actually developing this full-time, it would probably be just under a year at this point of full-time hours. So we have the engine itself, and then we have a game that we're starting to build on top of that, which we don't really have too much to talk about as far as the game goes yet. I'm actually building some stuff to make that a little bit more presentable, but I'm not quite there yet. So we've got a decent amount of game design document written up for that, just kind of outlining some of the basic things like some background lore, some systems we want, things, discussing art style and combat systems, things like that. So we've got some of that stuff, but it's not really in a presentable format yet. So at some point, we're going to jump back to that design phase, away from the programming phase at some point. But we're not quite there yet. Let's see. Don't you need more modern features like maps or dynamic arrays? Nope. I don't. And if I do, right, then I just write them myself. So, for example, if we take a look at the actual, in the engine core, I actually have containers in here, right? So I've got one for an array, which was going to kind of be a replacement for this D array, but I don't think I'm actually going to wind up doing that. But I've got a dynamic array here. I've got a free list, a hash table, a queue, a registry, which is where you can sort of register things with callbacks and whatnot, a ring queue, a stack array, and a U64 binary search tray. So basically, as I run into a need for a container, I just write one. Not a big deal. Let's Let's see. Apotham, good to see you. Welcome. Still a lot of dedication and really cool. Yeah, I mean, that's... I'm stubborn, I guess, right? Or maybe that's a... Yeah, I don't know what it is, aside from stubbornness, right? I kind of got past that point of like the whole shiny object syndrome thing that you get after you work on something for 6 months. That's kind of come and gone. Every once in a while, I kind of want to jump ship to like write the new thing, right? But like now I've kind of got the sunk cost fallacy going on where I've invested so much time and effort into this that I can't walk away from it, right? Even if I wanted to, right? Which I really don't. So the end goal with this is to make a game engine from scratch, build a game on top of that game engine, and then ship it on Steam. And so that's the goal. And documenting the entire process of it, right? Singy, how's it going? Good to see you. Let's see, making a PSP homebrew game in C, and the game engine code is good until now, but I have undefined behavior and cannot find it. The homebrew SDK does not have sanitizers or memory validation, such as Valgrind. Ooh, that sounds fun. Feel stuck and don't know how to debug it. I think it is a stack-based undefined behavior. Those are always fun. That's one of the, well, okay, it's not really going to help you with stack issues, right? If you've got stack corruption, that's something entirely different. But memory issues are one of the reasons that I wound up rolling my own allocator, so I can actually like see what's happening with that. And we're going to be writing a bunch more utilities around that, and debug utilities around that eventually at some point. So stay tuned for that. Hey, love your devotion. What distro? So I'm on Arch, Arch Linux at the moment. I used Ubuntu in the past. I do sort of, I guess, unofficially support that as well for this. But yeah, at the moment I'm on Arch, by the way. Okay. And I literally named my machine Arch, by the way, for the memes. So there's that. Okay, so we have shape type. We've done this. Okay. So I guess that's it for hit shapes for now. Let's see. We also need to do, I guess we could do point lights next, right? Because that one is, not quite as annoying, but let's see. Where is, do I not have a point light in here? I thought I did. I do not. Cool. Okay. Let me do zone. Let me think. I probably ought to pull one in. I guess I can pull one in from testbed, right? Here we go. We've got a point light here. So I'll pull this in. And we'll convert this to be an entity instead of a node attachment. So I just kind of paused for a second because I'm just kind of thinking about the way that this is laid out, and this kind of doesn't make any sense. This is kind of another candidate for like setting up children entities, right? So I'm going to put this in here. I'm going to do children equals and open up an array. And then I'm going to paste this in here. So the type of node here is going to be point lights. Here's its color. Position, we're going to get rid of that in just a second. Constant F, that doesn't exist anymore. And then we have our linear and quadratic. So point light is the type of entity. That's fine. Then I also want to take sort of this fire audio emitter right here. Because this is an audio emitter, this really ought to be placed inside children, right? And then we'll do fire emitter, right? And then up here at the top, we'll sort of wrap these both in a sort of parent entity, right? So that the point light kind of travels along with the fire emitter, right? And we'll, like I said, we'll be adding more properties to these point lights eventually. But what we really need at the moment is we really need this K transform to be defined here. Right, and we also need, we should probably also have a name for this, just for good measure. We don't have to, but let's call this fire light. Right? Right, and so we've got a transform here. So these first three are actually these first three here are the X, Y, Z, right? Position. So we want to just replace that. Eliminate position because we're not going to have a bespoke position for that anymore. We're going to get that from the transform. Rotation for point lights does not matter. So all we have here is just a identity quaternion rotation. And then scale is also ignored. So we just have a 1.0 scale. But we literally won't use that at all for this. Okay. So I think that makes sense, right? That's a little bit better in terms of how our entity is laid out. So when we go to process this, we essentially need to draw out these three properties, which is relatively straightforward, and actually can kind of work the same way as these guys do. So I'm actually going to let's see, the color is a vector 4, so let's actually just take, wait a minute, wait a minute, this looks wrong here, give me a second. So this is rectangle, oh, this is my nested switch, okay. All right, so actually what I want is, yeah, I do want this. Okay, so I'll paste that here, get rid of this extra break. And we're going to call this color, right? And this will be color, right? So extract color from that. And then we'll need to extract linear and quadratic from it. So that's just going to be essentially this logic, right? So we're going to rename this to linear, right? And linear, we're going to default to 0.35 f, right? Which is the same value that we have over here. It's just a reasonable default, right? So we have linear here, and then quadratic. I'm also going to use this sort of property over here as the default. Oops. Yeah, quadratic. Right? And the default for that is going to be 0.44 f. Right? And that's all that we're going to have to extract that is point light specific for now. Now I know, like I said, I know we're not doing anything with these values just yet, but that is what it is. I am going to change this to, vector 4.1. So we'll default to sort of a white light, right? And so that is the point light. Nothing too crazy advanced there. Nothing advanced at all, if we're honest. So volume is actually going to also be pretty straightforward. Let's see. We've got an example in here of volume somewhere. That's this guy. So it's basically just pulling out a bunch of properties. We don't need to pull these. It's actually all of these properties that we need to pull. Let's see. By the way, exactly. Yep. Hyperland is a good choice. It's what I'm using right now in Arch. Yeah, so I'm using KDE. I did use Hyperland a couple years ago, actually. There's some streams of me using it. And it worked pretty well, but I found the workflow a little bit annoying when it came to actually opening up the game window. I just didn't like sort of the aspect ratio that you get with a tiled window manager with that. Plus the resizing of NeoVim constantly was kind of annoying as well. Do you have any advice on how to debug this undefined behavior? If it's stack-based, that becomes really complicated. 9 times out of 10, you're usually overwriting some segment of memory that you don't think that you're actually writing to. It's usually like a wrong size of somewhere, and you're like zeroing out. You might be zeroing out, the memory the size of a particular struct, but that memory that you're zeroing out is pointing to a stack variable that's half that size, right? Which is going to clobber stuff after it, that kind of thing. That's usually what can cause it. So I would look for stuff like that. Just using the wrong size of somewhere can kind of bite you. That's the first place I would start anyway. Would you recommend an approach for a recent graduate to get a job as a back-end engineer to focus on books and making projects, or to just make projects heavily? So when you say back-end engineer, are you talking like back-end as in web development or something else? That's a stack UB, yes. Yeah, that would be. Wait. Foo data segment string. But inside foo itself, it doesn't take this string, it takes a different string. That depends on what foo does, I guess. If you're talking web development, so 9 times out of 10, the best way to sort of land one of those jobs is to actually have an example of something that you've built on your own that proves that you know how to do the thing, right? You still got to pass the interview process. So depending on what company you're going to be applying for, that can vary greatly as far as advice goes there. But my stance on it, even if you're not talking web development, my stance on development in general and skilling up and getting better at things and proving that you're up to the task only happens through getting your hands dirty and actually writing code. If you're not doing that, you can sit there and read theory all day. You can sit there and read about data structures and algorithms, but until you actually start like implementing that stuff, it's never going to stick. And you don't want to memorize solutions. You want to be able to get to the point where you can think critically about stuff. And I'll say this, doing this streaming stuff has actually helped me in interviews, believe it or not. Because when I'm streaming here, I'm constantly describing my thought process as I'm working through stuff, as I'm working through problems, so that you guys can kind of follow along. And that has actually helped me immensely, believe it or not. So I'm not recommending that you have to stream, but maybe pick up the habit of talking to yourself under your breath or whatever, while you're coding stuff out to sort of get good at explaining your thought process. Just don't go so far with it that you're going to wind up doing that in an office and annoying people. You know what I mean? Like draw a line somewhere, but... Foo copies a string into a buffer, but inside the debugger, when I hover, the string argument is not the string I set. Yeah, so you're probably clobbering memory somewhere. How long is one of your streams? So I usually stream for about 2 hours, give or take. Last night, we actually had a fairly large raid from Jonathan Blow, so I actually wound up going till midnight my time last night. So that was quite a bit longer, but yeah. If someone wants to prevent a face from being processed, does that happen in the vertex shader or in the geometry shader and just prevent rasterizing? If you want to prevent a face being processed. So by being processed, you mean like even fed to the vertex shader or just discarded in vertex shader? Like there's a bunch of ways to do that, right? Like it could be backface culling, there could be clipping, there could be frustum culling that's done on the CPU, or technically you can do that in compute as well. There's a bunch of ways to do that, so it really depends on what you're trying to do. There's not really a one-size-fits-all answer to that question. Tinspin, you ordered a TPM 2.0 module from AliExpress just for $10 just in case. Yeah, fair enough. I don't blame you. Don't blame me at all. Random question, are there any buffers in your engine that are kept in host visible memory, or is it always preferred to upload to device local? My staging buffers are kept in host visible memory. But yeah, that's pretty much the only one. Otherwise, I go through the whole, upload to device local, because device local is really going to be the fastest for access. Let's see. Thanks for your advice. I'll keep in mind to get keep it in my mind and focus getting my hands dirty on projects. Exactly. Yep. Don't be afraid to read up on things, right? But don't get stuck reading up on things. Actually implement the thing. Basically, I tried to discard at the vertex shader, but I lost more FPS due to sphere checks. Yeah, so usually, discarding at the vertex shader is kind of a last resort. Like, you should try to find a different way of doing it other than that if you can. Because at that point, it's already kind of been processed. Even though you're discarding it, you've already processed it. Like, you've already run through it, right? It's not just automatically. You should probably find some way to keep from even handling that in the first place. Because discarding usually involves some sort of check somehow, right? Some sort of branch in logic, and that's where you're gonna have a little bit of a performance cost, at least on the GPU side. All right, let's see, where was I? Oh, we're gonna do. Wait, we were doing volumes next. Okay. I get lost kind of easily sometimes when I read chat for more than 2 minutes. I think my ADHD kicks in and I just can't get back to where I was. Okay, so volume type. We only have one volume type, so for now I'm not going to worry about doing, writing some sort of function to sort of parse that out. I'm basically going to go ahead and just do it manually, kind of like I did here, although now that I'm going to be doing this twice, because we also have a shape type here, I might actually move this to a function. Let me actually do that. Let's see. This part of the function. Yeah, this part of the function is what I want to split out. Let's do that. So we'll do kind of similar to what we did up here. So static, Illumina shape type from string We want a constant character array string. Oops, did not want those quotes in there. All right, and then we'll paste this. And this will just be str. And then instead of setting equals, we'll just do return here. Right, and then this will be str here. Oops. This one, how did I guess I did. There, okay. So that's from string. We should probably also toString this while we're at it, even though we only really have 2 types. That way we could just add on to it when we need it. I should probably also move these functions somewhere else besides just here. But for now, this will work. So we want Illumina shape type to string, right? So Illumina shape type, type. And then we'll do a switch on type. Populate that. And then here, we're just going to return, oops, if I can spell sphere right. And here, we'll return rectangle, right? So that way, I don't have to repeat myself like this. All I have to do is do shape type equals shape, I guess it'll be Illumina shape type from string, and then pass shape type string. So we can get rid of all that. And then also, I should probably also string free here. Shape type string. Wait a minute, does this dynamically allocate that? Yes, it does. Okay. Okay. So that's good. So actually, I could just take this bit of logic here and move this up to our volume, wherever that was, here. Right, so we need shape type there, and then we will also need this same logic. Thank you for the follow, appreciate that. We'll also need to extract either radius or extents, right? Oh, I had this as a vector 4, that should have been a vector 3. So this should be a vector 3, which also means that this is wrong. Okay. Cool. So, that's shape type, radius, and extents handled out of this list. So now we need volume type, which again, I think I'm probably going to go ahead and create some functions for that. So static Illumina volume, what did I call that? Scene volume type. I don't know that I like that actually. Let's roll with it for now. We can rename it. So we'll do scene volume type from string, const character array string, and then we'll do if strings equal I. We'll use string, and then we'll say if that is equal to, and this is going to be trigger. Then we return scene volume type trigger. You know what? I'm tempted to rename this now, but scene volume shape type. Wait. Are we actually using this anywhere? Or am I just tripping? Didn't we have... Yeah, we made this generic. And I have this as a generic version. So why do I have those other ones? These must be leftover relics from before. So what these really should be is that not... Why doesn't it like that? Unknown type name. What? So that's Illumina scene H, line 60. Oh, it's a core resource type, that's why. Oh, I'm editing the wrong thing like a dingus. That's why. This is like the old scene attachment stuff. This is not actually even what I want. Okay. Now I'm less confused. Okay, so this should be Illumina scene volume type. Right? And then, yeah, that makes a lot more sense. And this is the only type that we actually have so far. So, we will also, as our default, we'll spit out the name of the function and we'll say unknown scene volume type, spit out another string, defaulting to trigger, right? So we use function, oops, that one, and str. Right, so we've got sort of a default there, and then we'll obviously have the inverse of that, which is just a scene volume type to string. Right, so this will be Illumina scene volume type. And we'll switch on this type. Right, we'll do this. And then instead of break, we'll return trigger. Let's see. Luna Moon, good to see you. How are you doing? Dingus Dev checking in. Awesome. Dingus Dev, I actually have something you might be interested in. I'm trying to think of a use for it, but I randomly searched. I searched for a domain called Dingus Games, dingus.games, and it was available, so I bought it. I don't know what I'm going to use it for yet, but it's there. figured you might appreciate that. I might do like a write-up on dingus-oriented programming, but yeah. Anytime somebody joins now, they are joining the army of dingai. It's kind of the new thing that I've come up with for followers, right? So whenever you join, it says, welcome to the army of dingai. You tried to get dingus.dev? Yeah, I searched for that one. It wasn't available. Yeah. I figured dingus.games was a pretty close second, though. Still don't know exactly how I'm going to use it, but I saw it and I couldn't not buy it. I figured you might appreciate that. Yeah, it's too bad you can't get dingus.dev. That would be awesome. Okay. So I guess here we can just do, we're going to have to treat this as a string, right? So I'll have to do volume type. So we'll have to do vol type string. And then we'll say, you know what? One more thing I want to check. In this case, in this function up here, oops, not this one. This one, where we're processing the string. If we have a string, then we want to do this. And only if, right? And then there'll be other cases in here as well. So if we pass a null to this, we're also covered, right? So that way, whenever I go to use it, I don't have to, sort of separately check it. So I can come in here and have the volume type string and then go casein object property value get string. Get the object called volume type, and then output that to the address of vol type string.
You dingus?
Yeah, see? It comes up with the dingus thing there. Yep. Thank you for the follow, by the way. I appreciate that. First time chatter. Welcome. Hope you're doing well. Enskimnator? I'm not sure if I pronounced that correctly, but how are you doing? Good to see you. Lucky Duck, I am good. How about you? Thank you for asking. Nailed it. All right, awesome. Cool. I tend to butcher pronunciations from time to time, so I always try to, make sure that I get it right and do my best to commit it to memory. Even though my memory is a bit like a goldfish. Can you use auto attack or bots in MMORPG games? Generally not. That's usually going to get you banned. Okay, so we want volume type, scene volume type, I guess it's going to be, or was that, no, Illumina scene volume type. Is equal to scene volume type from string. And now we can just pass vol type string. Right? And now no matter what the outcomes of any of this stuff is, even if it doesn't find it, right? And we wind up with a null string, we're still covered, right? So I might wind up actually changing some of these other functions to kind of work the same way. All right, so we have volume type, shape type, radius and extents, hit shape tags. So that is going to be separate from our typical tags, right? So it's a separate list of tags that's specific to this type of entity, where it's going to basically say anything that has this tag can interact with this volume. So long as it has, some sort of, or I guess, not anything. It's any hit shape that has those tags can interact with the volume, right? So it's got to be a hit shape specifically. So I guess what we can do is hit shape tags. And I'm actually going to just steal the tag parsing stuff from up here, because it's like 90% the same, right? So we're going to say hit tag string. Whoops, hit tag string. This is going to be hit shape tags. We'll go ahead and split this into parts, do the same string parsing that we did before. This is going to be hit shape tags, right? And then same thing there, right? That's all there's going to be to that. So that's nice and simple. And then we just have the on enter, on leave, and on tick, right? So I'll probably just do those. I guess, oh, you know what? This probably ought to be up with the shape type stuff, actually. Shouldn't move this down. Let's put this up here. We'll do volume shape properties. Okay. So down here, we'll do a constant character array, and we'll do on enter command first, right? And then we'll do casein object property value get string. We'll pull that from the current object. The name is going to be on enter, and we're going to write that to the address of on enter command. And we're basically going to repeat this 2 more times, just with different variable names, right? So this is going to be on leave command, right? And then we have on tick command, right? So we'll extract those, and then of course the only thing left here to process is the children. So obviously we'll need to point all of these to actual entity properties, but I'm just kind of handling all the extraction portions of this first, and then we'll kind of go from there, depending. So okay. So the next one is going to be, I think we just have water plane and audio emitter to do left, and then we're going to do height map terrain at a later date. All the rest of these are done. Yeah, okay. So audio emitter is probably going to be the next most complicated one, because it just has a lot of properties. Not that those properties themselves are all that complicated, but there's just a lot of them, right? So with that, obviously we have these standard ones here. Oh, I have this in here twice. I don't need that twice. Let's see. Oh, let's see. Hypnotic Games is raiding with a party of 44. Hypnotic, how are you doing, buddy? Thank you so much for the raid. What were you getting up to on stream? For those of you who are not, following Hypnotic, he is another game dev here on Twitch. He does 12-hour streams of game dev, and he's typically making something in Godot. He kind of bounces around a little bit with different kind of experimental projects and game jams and things of that nature. It's always kind of interesting to catch up with him. So if you're not following him, go do it. I highly recommend it. Dealing with UI stuff today. Yep. You split your stream these days, two 5-hour streams a day. That's probably a lot easier to do than one 12-hour stream for sure. And He also gives great beard tips. Yeah, I mean, do you think I need? Do you think I need? Or am I good? I don't know. Thank you so much for the raid. Welcome, raiders. I hope you guys are doing well. So I can give you guys just a quick introduction as to what we're doing here. I'll try and keep this as quick as possible just so that you guys kind of have some context. So what we're working on is called the Kohi game engine. So it is a game engine written in C from scratch using Vulkan as its initial rendering backend. The idea behind this series is that it's to be an educational series and illustrate a way to build a game engine. It's not the only way to build a game engine. It's not even necessarily all the right way to build a game engine. Sometimes we will sort of experiment with things, try things out to see if they work or not, do a deep dive on that. After the fact, review the results and then act accordingly. And so there's lots of things that we've sort of experimented with on the stream that some of them work out really well, some of them don't work out so well. And so the whole idea here is to build something from file new, not using libraries, to show the entire process and all of the things that you run into along the way, including all the troubleshooting and all that stuff when it comes to building a game engine. The engine itself is, in fact, I should probably drop this link in chat. So the engine itself is free and open source. So thank you very much for the follow. And so it is available on GitHub. It is Apache 2.0 licensed, which means that you can use it either commercially or personally. It does not matter. All that I ask is that if you use it, you say you used it. That being said, it's fairly early days in terms of features. We're still kind of building a lot of the core things that we're going to need, and I'm only building the features that I need to make the game that I am making currently. So I've got a couple of, albeit old screenshots here that shows our basic PBR pipeline with some cascading shadow maps, a few UI widgets here that we've got going, some UTF-8 text, things like that. And so, we still have lots of features that we want to get into the engine, but we have actually started, kind of moving towards actually developing a game on this engine. So the whole goal of this is to not only build the engine, but also to build a game on it and ship it on Steam. Thank you for the follow. Appreciate that. And so, that's kind of the goal here, right? The engine is only half of it. We do stream to YouTube and Twitch. We simulcast to both of those. All of the VODs will wind up on YouTube long term. We do have a Discord with about 1,000 people on it, give or take. And then, of course, a link to the GitHub and a Patreon link there. I don't have any sponsors or anything aside from you guys. So, that's the only financial support I get from doing this. The other things I should mention is I'm not ever going to paywall anything having to do with the engine. I'm never going to have any sort of licensing fees or royalties of any kind ever. The engine will always be open source and free. The games that I make with the engine, that may not be the case. And in fact, that's not going to be the case with this first game that we're going to make with it. But I will release, once the engine is sort of ready to be used outside the context of just that one game, I will release some templates to sort of get you started. A couple other things about the engine is it is cross-platform, so it runs on Windows, Linux, and Mac OS. And we have other platforms planned for the near future. So that's just a little bit about that. I hope that makes sense. So yeah, this is designed to be an interactive stream, so if you guys have questions along the way, I do stop coding every once in a while and kind of check out chat, try to keep caught up with that. And yeah, I hope all that makes sense. Okay. All right, so I guess to give a little bit of context as to what we're doing at the moment. We had a generic scene that was included with the game engine, and we had a generic renderer that was in the form of a render graph, right? So it was a configurable render graph that you could set up. In fact, I think the application config still has it. I don't think I've deleted it out of here yet. So yeah, it's still in here, although it does nothing anymore. But you can configure all of these render graph nodes and hook them up with sources and sinks to one another, defining inputs and outputs from one node to the next, and all of that stuff to determine how the application should render. And this was one of those things that it was an awesome experiment. It worked well. However, having something generic like that generally tends to mean that there's a lot of overhead in the sense of code. So you've got to set up all these interfaces and all these sort of implementations of those interfaces, all of the sort of generic work that you have to do to keep this stuff generic. There's a lot of overhead associated with that, both from a code perspective and a performance perspective. And so when you think about it, ultimately, the application is fully aware of not only what data it's going to need, what types of data need to be represented, whether it's just using 2D textures or whether it's using just static meshes, whether it needs animations, whether it needs, who knows, right? So the game is going to know all of that stuff, or the application is going to know all that stuff. It's going to know how that stuff should be organized in a scene. Put an asterisk there, we'll come back. And how that stuff needs to be rendered, what order it needs to be rendered, how it needs to be sorted, how it needs to be split up. Does it need to be split up by material? Does it need to be culled? Does it need to, all these various things. If you think about it this way, the data that you would organize your data a lot differently for rendering a first-person shooter than you would organize it for, say, a top-down shooter or an isometric action RPG, which is what we're building, right? And that's different yet from something like that's super open world, like Grand Theft Auto, or something like a racing game, right? All of those things have different requirements for how they need to be rendered, how their data needs to be represented and transformed in memory. And so, when I got thinking about it, I'm like, a generic solution doesn't really make sense for both the scene and the renderer, right? Because those are both things that are very, very application specific, right? And so we're pulling out all of that generic stuff, and we are creating bespoke, what we call bespoke versions of those things. So we have we've already done the renderer for the game that we're building, and now we are doing the scene, right? So this render graph business, this is already actually just defunct. This is out of here. I just haven't removed it from the configuration yet. But in terms of the scene itself, we are sort of refactoring that or rebuilding that from scratch now to deal with very specific types of entities, because we're going to know all the types of entities that we need. If we need new types, we can add them. And we don't have to worry about setting up all these interfaces and injecting code and all of this other stuff, right? So that's essentially what we're in the middle of now. And so this is our file format for our scene. And so we've got some properties up here that are sort of top level properties for the scene. And then we've got our list of entities here, which can be nested, right? And so this is a proprietary format that we've written. We've also written a parser to handle this complete with a API to be able to parse that in game or in code. And so we're utilizing that now to do this, right? So the first pass of this is basically going to be this human readable version, because we don't have an editor yet. We have to input this stuff by hand. The second phase of this will be building an editor that generates one of these files. And then the third phase is once we are sure that we have all the types in that we need and the data is the way that we want it, we will build a second file format that is going to be a binary representation of the scene that we can basically just bulk load straight into memory and have all of the configuration that we need for the scene. And then the editor will generate that, or we'll have the editor generate this and then bake it into that one way or the other. So that's kind of the plan. So yeah, if you guys have any questions about it, feel free to ask. What type of game am I making? It is going to be a 3D isometric action RPG. And I say open world with an asterisk, right? Because it will be zoned. So there will be, different zones that you have to load into. but you'll be able to explore, right? So, Jeet, how's it going? Good to see you. Hope you're doing well. Do you know Sudo and Tokyo? They too do the same thing as you. Sudo and Tokyo. I mean, I know them as their other concepts, but are they folks that stream online or something? I don't think I'm familiar with that combination. Can you elaborate a little bit? Gonna make a 3D snake game when your engine comes out. That sounds awesome. Yeah. I mean, you could probably do it now, but it'd be painful. And plus, we've got some stuff that we're going to have to do, to actually prepare for shipping that we haven't done yet. But yeah, I mean, theoretically, you could build a game with what we have now. It's just, it would be painful, which is why I'm making the changes that I'm making, right? Because one of the things about this is that one of the reasons that we're building a game with this engine is to sort of run it through its paces, right? Find the pain points and eliminate them. Okay. So the audio emitter is going to have all of these properties. Now we have audio resource name. We don't do resources anymore. That was another change we made. They are assets, right? So we have audio asset name and audio asset package name. So we'll need to extract those. So I guess we'll go ahead and do those first. And then we have some radii, or radii. Then we have a fall off, and then a couple of flags. Let's actually move volume. Yeah, let's move volume up. And we'll keep the booleans next to each other. Thank you for the follow. Art Burklaus with a raid of 13. I appreciate the raid. Thank you very much. Welcome, raiders. For those of you who... I hope I can do a shout out. We actually just got raided a couple minutes ago. So for those of you who don't know Art, I suggest his channel as well. He is making an old school sort of Doom style-ish first-person shooter, and he's making it completely from scratch in C++. So definitely fits in well with the theme of what we're doing here. So definitely go and give his channel a follow for sure. Because some of the stuff he's making over there is really cool. He's made a lot of his own utilities too, including a graphics editor, where he can actually make his, he's got an image editor that he uses to make his textures in. So just all kinds of really cool stuff over there on his channel. So definitely go check that out. Yeah, and thank you for the raid. I appreciate it. So what we're in the middle of now is just sort of parsing our scene file here, which is a new scene format that we've come up with that's a lot better than sort of our old format, and we're just sort of rewriting our scene from scratch to be application specific instead of trying to be generic with it. Yeah, so progress has been pretty good. It's we're just kind of going through all of the various entity types and parsing out their properties. So when we have a static mesh, the assets we need to pull in for that, or water plane, the various properties we need to pull in for that, or a point light, or a sound emitter. We have all these different types of entities that we are pulling stuff in, pulling different sets of properties in for. And so we're just basically reading that in code now, and then we'll use that to actually stand up those individual entities in the actual scene. So yeah, so far so good. You pay others to create game assets. So right now, no. And I'm actually going to do everything I can do to avoid doing that. But there may be circumstances where I have to. But yeah, I'm going to try and also make all that stuff on stream. So we'll see. At some point, we're probably going to walk away from code entirely and be fully in level design and modeling mode. But that's probably pretty far off. because what I'd also like to do, and I haven't mentioned this yet, but what I'd also like to do is actually, I want to write a exporter for Blender, so that we can actually export Blender scenes directly into the format that this engine expects, so that we don't have to like export it from Blender and then import it into our engine. We could just export it directly from Blender to our engine and be done with it. So that's gonna be another thing, but yeah, we'll get there when we get there, I guess. Okay, so the asset names here for, or the asset name for the fire emitter or the audio emitter is going to be a K name, right? So that's a K name is just a hashed string that's case insensitive, right? So we hash it just to make string comparisons fast, right? So we'll say, actually we don't need to call this audio asset name. We can actually literally just call it asset name, I think. That's a little bit less verbose. So we'll say asset name, and we'll default this to invalid kname, and we'll also have kname asset package name, and we'll default that to invalid kname. And then what we'll do here is if we are unable to parse case and object property value get string as kname. So we pull from the current object that we're working in, and we want to pull from that the asset name, right? That's the name of the property. And then we're going to write to the address of asset name. If for some reason that does not exist, that's actually going to be an error, because we need an asset name is required to load an audio asset for an audio emitter, right? So if we don't provide a name, there's not much we can do about that. So that's just going to be an error, right? So we have to error out at that point. If a package name is not provided, then that's actually not a big deal, because we just assume that it's going to be the game package, which in this case is Shadows of Illumina, but we also have a sort of default that's configured in the system to fall back on. So I can actually just grab this line here and do away with the if check, because we don't care whether it fails or not. We're just going to use it as is. So we have asset package name, and then package name, right? And so we can put here required optional defaults to package application package. So the next thing is just going to be a couple of floats, right? So we have this inner radius and an outer radius, and then the fall off is kind of used with that. So the inner radius basically states the volume plays at 100% within this radius, so 2 units of the center of wherever the emitter is. And then the outer radius is basically how far away from the center you can hear it, right? So it basically goes from 100% volume to 0% volume between these two, right? And it just sort of falls off. And we've got a few different fall off modes. I don't think we actually exposed those to configuration yet, but it's something that wouldn't be too difficult to do. And so we can just add that later. I just kind of want to get them in here and working for now. So for now, we'll just sort of default to linear fall off and call it a day. So we'll have an F32, and we'll do inner radius, and we'll default to 1.0. And we'll do a F32 outer radius, and we'll default to 2.0. And that way, if we set these, right, then all we have to do, what did I do? Okay. That way, if we don't actually find these, right? So we do casein object property value get float object. So this is going to be inner radius, and we write to the address of inner radius, right? And we don't care about the result, right? Because if it's not able to find this, if that property is not defined, it defaults, right? So it's kind of an optional property with a built-in default. And then we'll do the same for outer radius, because it works the same way, right? Volume is actually going to be the same way as well. So F32 volume equals 1.0. 1.0 is max. Whoops. There we go. 1.0 is max, and then obviously 0.0 is minimum, right? So volume, right? So again, that is optional as well. The next two properties that we have a is streaming, and that's going to default to false. And then B8 is looping is also going to default to false, right? And it's going to be the same thing. Casein object property value get bool. So we want to pull that from the current objects. The name is going to be is streaming, and we're going to output to the address of is streaming. And then we can basically just do the exact same logic for is looping, and that's it. So that's all of our properties over here for the fire emitter. Okay. So like I said, that was probably the next most complicated one. Okay, so the next one and the last one, I think, is actually going to be water plane, because like I said, we'll come back to height map terrain later. Because I think I'm gonna wind up completely redoing how height map terrains work, actually. Because I really want to rethink the data structures for that and the way that it's organized, so that it's more renderer friendly, and also so it can support more materials than what we currently support for it. And I'm thinking about having like a bespoke material type specifically for terrains. But I still haven't decided how I want to actually tackle that yet, because I want something that's going to look good, but it's also going to be performant, right? And what we had before was okay. But okay isn't really going to cut it, right? We need something that has, high fidelity in terms of geometry, but also textures, right? Which is kind of hard to accomplish on a large terrain. There's a few different ways of doing that. I just have to kind of evaluate which one's the best. Let's see. Sorry, but you probably missed my question about command buffer submission above. Good chance I did. Let me see if I can find it. Does Kohi support multi-threaded command buffer submission? If so, what's the architecture behind it? So we don't yet. I have plans to do that, but I was going to wait to multi-thread it until I have at least one other rendering backend implemented that also is going to support that. And that's going to wind up being metal, right? So I need to make sure that that's going to be something that's supported. I already have like a flag that you can turn on and off from the renderer front end about multi-threading. But here's the thing about multi-threaded command buffer submission, right? Yes, there is some overhead with that. We do kind of get around that with having multiple frames in flight. My idea for multi-threaded command buffers in general is purely going to be for non-rendering tasks, at least initially. So the idea is going to be that anytime we do a texture upload, we're going to jobify that to a different thread. That particular thread will be coordinated with the render a back end to have resources created on that, in particular a queue that's created on that same thread. We'll queue up some upload operations and fire those off on different threads. That's kind of my idea for the initial aspect of it. As far as the core rendering cycle, most of that's not going to actually have a reason to be multi-threaded. Other than, the only other thing I can think of is for some of our passes, like our cascaded shadow map passes, right? Where we have 4 different passes that we have to render all the geometry in the scene for. That might be something I multi-thread. But I haven't really decided if that's going to be worth it or not, right? Because for this game, it's a isometric action RPG, so I think frustum culling is actually going to cut down a lot of that for us, because the camera is going to be looking mostly, in a ground, kind of looking at the ground most of the time, although we may have some scenes where it kind of cuts up or does different angles. I haven't really decided yet, so I'm holding off on doing that until I actually determine that I need it. And that's kind of the overall theme of what we're doing with the engine, is I'm not putting stuff in unless I have verified that I need it and it would actually be a huge improvement. So there's things that I've done that I've kind of kept in mind for multi-threaded rendering. It's actually on my to-do list. It's eventually going to make it in, but I don't know if it's going to make it in for this game or not. I hope that's a long-winded answer, but I hope that answers your question. All right, so water plane. Water plane is going to be, for now, stupidly simple, because the only thing that it actually contains, other than the basic properties, is just a size. So that's just an I64. Which all numbers that are not floating point in this are represented by I64s in Kson, right? So we'll have an I64, we'll say size I64, I guess. We're going to default that to, I guess, 128, right? That's just how big the water plane is in units, right? And then we'll do Kson object property value get int. And so we'll use the object. The name is going to be size, and the out value is going to be the address of size I64, right? So again, whether or not we get that doesn't really matter, because we have a default. Eventually, we're going to need the ability to configure water materials. Right now, it just kind of uses the default and sticks with that, and that's fine for right now, but eventually we are going to have to add some properties to this. So maybe I'll put a to-do in here, water material asset name asset package name. Ruche, thank you for the heart. That's my wife, by the way, in case you guys are wondering. She's in my chat. She's currently raiding at the moment, but she does actually hang out in my chat sometimes. All right. Okay. So I guess that's actually it. For all of the types that we have defined, there is one more type that we talked about last night that we didn't define yet. So we talked about spawn points last night. And initially spawn points were nothing more than just a node and a transform, right? But we decided that we might want some other properties added to that eventually. So a spawn point is essentially, it's basically a way to say, we want to spawn things at this current kind of position in space. And we can also provide a rotation, and we can technically also provide a scale. Oh, that's probably going to be ignored. In fact, Yeah, we do have a scale on this, which actually makes 0 sense. So I'm actually going to get rid of the scale, right? So we've got a quaternion rotation here, and then we've got XYZ position. So, we've got a couple of different spawn points in here. The type is spawn point, and what I'm thinking is like we might have additional properties that say, randomize the position by this much, or randomize the rotation by this much, or maybe we apply tags to it somehow, or something like that. We might have some other additional properties that we want to actually have. So what I'm going to do is I'm actually going to create a new entity type. I hadn't planned on doing this initially, but I am going to add one. And it's going to be very simple, right? So we're going to have Illumina, entity type, and then I'll do spawn point. All right. And so obviously that's going to, provide us with a couple of different things that we're going to have to change. Now, I'm just going to go ahead and add, let me see, where did I put that again? Right after point light. So I guess I'll just add that here, right? So I'll do a case here. Illumina. Spawn point, right? And we'll break. And I'm just going to put a to-do, add any additional properties to be parsed here. We're not going to parse those just yet, but we probably will add them as we need them, right? So I want to go ahead and separate this out now, so that way it's not an issue. So that is the deserialized entity. That's one thing that we need to handle. We also need to add something to our entity type to string, right? So we need to add that here. So we need case for the spawn point. Oops, I need to move this up there, and then return spawn point. So we've got that. And then also I need to add it here. So I'm just going to take, let's see, I'm going to take this and come here. I must have done that wrong. There. Yeah. Okay. So this is going to be spawn point and type spawn point. Right. So just to convert those. I don't think we're going to have to worry too much about this. We'll obviously need to add a function to add one of those to the scene. But I don't think. All right, so this is... Oh, these are... Okay. These were promoted to base. That's what we have. Those were promoted to the base entity. That's why that's bleating. Okay. Add point light. I guess... Let's actually take a copy of this since we're here. And we have add point light. Right after this, we're going to say add spawn point. Right? And so the spawn point is going to take in just the scene pointer, the name, and the transform. That's all it needs. So this is going to be, we don't have the new entity type, so we need to go and create that before I can complete that function. So this is just going to be a type def struct. I can't type tonight. spawn point entity, spawn point entity, right? And all this is going to have in it for now is base entity base, right? Because it has no extra properties for now. I just kind of wanted to get it in there. And then here we just need to do spawn point entity, spawn points. And then here, I can just copy pasta this. Spawn points, spawn point entity. And just kind of work our way down, right? So when we get the entity transform, we just need another case in here for that. So we could do case Illumina entity type spawn points, return scene spawn points, sub typed index, base transform. Oops. There we go. I think I might actually eliminate this default case, because what that will do is that will throw an error whenever we are missing a type, such as this. Oh, that's the reason I had that in there. Okay, I guess I'll undo that. All right, that's fine. There's the only two I'm missing, that's fine. I might actually get rid of those. Okay, so remove entity. These are erroring because that's promoted to base. We just fix that real fast. Oops. Okay. And then let's see. Point light, right? So this is actually going to be almost exactly the same again, except we have spawn point, right? This is going to be spawn points. This is going to be spawn points again. Okay, so we've got that. Let's see. All right, so now we can actually get back to our add spawn point. All right, so we actually, we need to finish converting all this stuff to the correct type. So spawn points, spawn points here as well. This was also spawn points. This is going to be spawn point entity. This is going to be spawn points, spawn point entity. The type down here is going to be spawn points. And then these properties don't exist. And then I'll just rename this so it makes more sense. Spawn point count. Okay. So that's for adding a spawn point, right? It's pretty straightforward stuff, I think. I don't need to go into detail because we've already kind of done that a million times already over. Right. So I do believe that that actually concludes all of the entity types that we wanted in here. So let's just see. We've got spawn points in there now. This is just a regular, kind of a regular entity for now. We do have, this is also a regular entity. Thank you for the follow. Appreciate that. Man, that's an interesting line number system. Yeah, so just a quick explanation of what that is, in case you haven't figured it out. So in Vim, it's very convenient when you're moving around. Like you use J and K to move up and down. The line that you're currently on gives you the line number, right? So 1517 is the current line I'm on, right? But let's say that I wanted to go down to this line, right? One thing you could do is you could just, hold J and go all the way down there, right? Or if I'm at this line, I can look over here and say, that's 16 lines down, and just type 16J. And bam, you're there. So that's what it is. Art, have a good one. Thank you again for the raid. I understand getting ready for bed. I'm not too far behind that myself. So, yeah, thanks again for the raid. I really appreciate it. It was great to see you again. All right. Let's see. Will you get Kohi Editor ready to help editing scenes of Illumina? Yes. So my plan for the editor is I'm actually not going to build a generic editor initially at all. I'm going to build the editor that I need for Illumina. From that, I'm going to pull out the components that I can make general and the components that I can transition to that sort of starter template that I was talking about before, right? And then that will be specific to that starter template, right? So the editor is going to be vastly different per game as well, right? So having like a centralized editor, like what you might get for Unreal or Unity or something like that, doesn't really make any sense the way that this game engine is architected, right? Because we're trying to keep the generic stuff to a dull roar. And so, you know, the editor for this type of game, which I'm going to make a template out of, eventually after I release this game, you know, it'll be geared towards making an action RPG, versus, you know, maybe a racing game, which was something I kind of played around a little bit with on stream, and we still might do at some point, right? And so we'd have an editor for a racing game that's a little bit different, right? It's a different set of tools. And so, yeah, we're going to have many different editors. And we're basically going to build the tools that we need, the way that we need them, and we're going to avoid doing stuff so generic that we kind of get stuck in generic territory in perpetuity, right? Fake Siva, how's it going? Hello. All right, so let's see. We have static mesh, we have hit shape. We have the volume. Static mesh again. We have water planes. We have point lights, and we have audio emitters. So that covers all of the entity types that we have for right now. Okay, cool. So now we're kind of at the point where we have the ability to add these things to the scene and actually get them to load up and all that stuff. So there's a few things that we need to do from here, and I think what I'm going to do is actually go here to the top, and I'm going to make a to-do list, right? So we're going to say to do, and so the first thing that we're going to do is we need to get the scene hierarchy graph in place, right? We already have the hierarchy graph. We just have to put it in place. We also need, you know what, instead of to do, I'm going to put left off. So we need to do that. We have the scene parsing done. We need the scene deserialization done. We need scene serialization. This can come last after all else is working. We need to handle directional light storage and skybox storage / asset loading. And then we also need the finish, or I should say finish provide queries for lights, skybox. We already have for geometry. So I guess that's probably it. And then we need debug render data representation. So this is going to be things like render bounding boxes, spheres, etc. I guess bounding boxes, spheres, and then also raycasts, etc. Speaking of raycasts, object selection is another thing we need to do, because that's actually going to be kind of up to the scene, right? Because the scene is fully aware of how that stuff works, right? So this is actually going to probably require a BVH, bounding volume hierarchy, which we don't have yet. So we need to think about that a little bit. I guess below scene serialization, there is one more, write scene to disk. Volume's too low to hear anything. Really? I'm basically peaking on my OBS. You may have to turn up your speakers, because I think everybody else can hear, right? I wanted to ask, do you have experience or knowledge in SOC or cybersecurity? Not really, no. That's not something I've really delved into too much. Can hear you all right? All right, cool. Thanks. Yeah. Mahmood, you found the bug? Good. Was it dingus-oriented programming is the question. We must know. Use the same name for a function pointer and a define. Don't know why this corrupted the stack. It depends on the code itself, but yeah, I would say don't do that. And that is, in fact, qualifying for dingus-oriented programming. All right. Anyway, it is almost 11 o'clock, so I think this is probably where I'm going to end the stream, because we actually came up to a really good stopping point. And we can kind of start to handle some of these other to-do items in the next stream. So with that said, let me go ahead and find somebody to raid. And I just want to say thank you guys very much for being here and following along. And if you haven't already, I would ask that you either follow or subscribe over on the YouTube side. Thank you for that, because it helps me grow the channel, right? And I'm trying to inspire people to get into this space, because we need more competition in the low level space, right? I don't think there's enough people out there doing this. We need more competition outside of the big three. And so my hope is, even if I inspire one person to want to do this, then I consider that a success, right? But the more followers and stuff I have, the wider my reach is. So I definitely appreciate that. All right, let me see who is available to raid. Let's see. I want to see if I can find something that's kind of related to what we're doing. I always try to look for that first, and then if I don't find something, then I kind of switch. I think I see where I might wind up going. Give me 1 second. Yeah, okay. Person I was thinking of is not online. So we're going to go check out. Looks like somebody's making a... Excuse me. Yeah, I think we're going to go with... somebody's making a roguelike RPG. So let's go check that out. using blackjack as the battle mechanic. So let's go check that out. And yeah, all right. So yeah, thank you guys so much for being here. I appreciate you guys. Yeah, let's give this person a warm welcome. I think I might have rated them once before, but it's been a while. So anyways, yeah, I'll see you guys next time. Thanks for being here. See ya.